Hello, this is a short screencast video showing you how to use Microsoft Excel to produce and construct that as population proportion confidence intervals. So all of these have pretty much the same format, where there's a place for you to put the number of people that have responded affirmatively to some question. I'm trying to remember what example this dealt with exactly. I think it was the proportion of people that used mobile boarding passes on the worksheet that we went over from section 7.1. And out of 80 people, 60 people said that they used mobile boarding passes. And that's 75% of the people boarding the plane. And that means the complement is 25%, which is the number of people who did not board the plane. With a 95% confidence interval, the critical z-value is 1.96 from the chart, and this is using the inverse norm function, which makes it a more accurate value. And the error is literally the formula, the critical z-value times the square root of the product of the sample proportion times its complement all over n, the sample size of 80, and it finds the error and then adds and subtract that error from the mean to produce the confidence interval. So this was the first example from the worksheet. The second example had to deal with the person who had a website and they wanted to have a banner on their website that was an advertisement, and they were curious what proportion of the people visiting the website clicked on the link on the banner. So 34 out of 200 people clicked on the link. That's 17%, meaning 83% did not click on the link. With a 99% confidence interval, the critical z-value from the table is 2.575. This is a little more accurate, again using the norm inverse function in Excel, and using the same formula for error, which is the critical z-value times the square root of the sample proportion times its complement divided by n. When you take that error and add it and subtract it to the sample proportion, you create the confidence interval for the population proportion. In the two you tried examples at the end of the worksheet, number 55 was dealing with some administrators who were interested in how many teachers had their master's degree, and 55 out of 100 surveyed teachers from this district had a master's degree. That means 55% of them had a master's degree, meaning 45% did not. With a 95% confidence interval, this finds, using the norm inverse, the inverse norm functionality, the proper critical z-value that would be 1.96 from the table, and then using that finds the error to add and subtract it to the sample proportion to create the confidence interval that you'll also see on the worksheet. And the second example from the U-Triest example at the end was about what proportion of people would support raising the minimum wage. And out of 800 people, 568 said they would. That means 71% said they would support raising minimum wage, and 29% would not. This is 0.9, which means the confidence level is 90% for the confidence interval, and that yields a critical value of 1.645 from the chart. But this is a more accurate value, again using the norm inverse function in Excel, then using the formula to compute the error. It then adds and subtracts the error from the sample proportion to find the confidence interval. So you can put in your values in here, and it'll change all of the values for the error and the critical value and the left and right boundary of that interval. And so this could be a nice little utility to use instead of using the graphing calculator or StatCrunch, which I'm about to show you in another video.